We are going to compare Arista Cloud Vision Portal, also known as CVP, to HPE's Apstra Datacenter Director. What Arista has done with CVP is basically sticking a GUI in front of the CLI. One still has to be an expert in BGP, MLAG, VxLAN, and EVPN, as they expose all the CLI parameters to operators each and every time you make a change to the fabric. Let me show you what I mean. Today we are deploying a 4-switch leaf spine fabric. Starting here inside CVP, Studio's modules are Arista's primary method for fabric configuration. Each studio consists of a sequence of forms where the operator must provide manual inputs that are then used to instantiate the change. Today we are deploying a 4-switch leaf spine fabric. In the inventory tile, we see that 4 physical Arista switches have already been registered with CVP. From there, we move back to Studios and select the L3 leaf spine fabric module, which builds the BGP underlay and configures the VTEPs. So as we build out this fabric in Arista CVP, please take note of both the volume of inputs the operator is expected to supply and the depth of expertise assumed through the process. As you can see, these forms require a significant number of manual entries from the operator, many of which demand a deep understanding of data center networking protocols and their operational mechanics. Each parameter presented assumes specialist-level knowledge with operational expertise. While not every field must be populated, all of these advanced options remain visible and accessible to any operator with access to the Studio module. Notice the level of detail exposed across critical technologies such as MLAG, BGP, EVPN, and VxLAN. Operators are expected to manually define address ranges, VNIs, and other foundational resources that are typically managed only by highly experienced engineers. This approach places a substantial portion of the network's operational complexity directly in front of the user, requiring careful attention and deep protocol knowledge to ensure configurations are entered correctly, and none of this guarantees any reliability in the system. We'll now return to the Layer 3 leaf domain section. In this step, the operator is required to enter a numerical VNI value rather than any descriptive name. However, if I type in an alphanumeric value or a word, there is no indication that the input is wrong. It is also important to note that this configuration is still in a staged state. Let's see what happens if I move ahead with the configuration. The error is quite clear. It is telling me that it should have an integer value and not a name. So let's return to that portion of the configuration, delete what we had set. Now let's try it again. Having encountered this issue previously, I know what kinds of values are expected. However, without prior experience, operators can and will easily make this error, not only in this field, but in many others like it, resulting in unnecessary delays during the deployment process. In Apstra, a mistake like this would immediately be flagged in red. Errors are caught during the configuration process, not at the end of it. Clicking into this L3 leaf domain and moving on to the next page form, I'm met with a similar need to add these leaves as part of the domain, set any ASN, turn on or off MLAG, configure any overrides, and now let's see what happens when we submit this. Okay. So we've resubmitted the configuration and the build has passed. It's time to submit this workspace for change management review. Once it's reviewed and approved, the build is pushed to production and instantiated on the switches. Success! Now, seeing as I have learned to avoid the issues that have caused me extensive delays, even while building this very basic 4-node fabric, Arista CVP exposes operators to over 75 different parameters requiring high levels of expertise. Now let's see how this is done in Apstra. The goal with Apstra is to reduce human error by removing it from the workflow. Operators aren't expected to be experts in BGP, EVPN, VxLAN, or deep protocol mechanics. Instead, they work inside a model that ensures every change aligns with architectural intent, policy, and operational expectations. To build the network, an operator moves to the Blueprint section, clicks Create Blueprint, and selects a predefined template. The template already captures both physical topology and operational intent. Once we confirm the correct template, we create the blueprint. At this point, only 3 operator tasks remain. First, the operator assigns predefined resource pools. Next, we set the network operating system. Finally, we place the physical switches into their positions. Unlike CVP, we didn't have to decide at the beginning which device would play which role. It's like casting a play. You write the script first, define the roles, and then assign the actors. You don't write the play around specific actors, limiting its scope. We're going to commit this change, and now these changes have been moved to production. Total number of manual inputs exposed to the operator? 0. And for fabric expansion, the process is similar. The operator navigates to the racks subsection, clicks the plus sign to add racks, selects a rack template type, the number of racks, and then clicks add. In contrast, expanding a fabric in CVP requires repeating the same studio forms used for the initial deployment, regularly exposing the operator to more than 75 manual inputs. Arista CVP's model depends on operator expertise. Apstra's context-driven model uses guardrails to minimize decision points and reduce exposure to human error. This is what enables faster deployment, fewer outages, and a significantly lower operational risk profile. This video will demonstrate the importance of context when troubleshooting complex data center networks. EVPN in the data center effectively makes all leaf switches behave like a single logical switch. Therefore, any endpoint can reach any other device across the fabric. We are sometimes dealing with tens of thousands or even millions of routes. But if an EVPN route advertisement fails, traffic can silently black hole. And because EVPN depends on the BGP control plane, partial failures, where BGP sessions remain up but specific routes are missing, are especially hard to detect and troubleshoot. Troubleshooting under these conditions becomes like searching for a needle in a haystack. Ironically, the affected device itself often remains fully connected to the fabric through its local VTEP. The failure exists entirely within the control plane, yet no obvious fault is reported. From an operational perspective, services simply fail without a clear signal, unless a controller provides the necessary context. Here we are looking at a 2-spine, 2-leaf VxLAN EVPN fabric built on Arista, managed by CloudVision Portal, and at this stage both endpoints can successfully ping one another. Now we will simulate a control plane failure that suppresses only the Type 2 and Type 5 advertisements from Leaf 1, while the endpoint connected to Leaf 1 remains operational and connected to the fabric. However, as a result, the endpoints can no longer ping one another. When we inspect Leaf 1's MAC address table, we see that endpoint 1 is still connected on Ethernet 5. If we review the show BGP EVPN output on Leaf 2, we see that it is no longer learning the destination MAC route. We see that Leaf 2 has lost the routes. The question is now, how would you detect this in CloudVision Portal? The reality is, you cannot. CVP lacks contextual awareness. CVP telemetry can detect MAC addresses appearing or disappearing, and it can identify a BGP session failure. However, it will not recognize that a specific Type 2 or Type 5 route is missing from the control plane because it has no knowledge that the route should exist in the first place. Without context, it cannot detect the absence of expected routes or BGP sessions. As you can see here in the BGP dashboard, there's no awareness of any of the Type 2 or Type 5 routes missing. As a result, operators must rely on experience to recognize this type of silent service failure. Troubleshooting becomes time-consuming because the source of instability is unknown and it requires manual, node-by-node inspection. CVP neither detects the issue nor assists in isolating it. Operators typically discover the problem only after users report service disruption. Although context always exists, the real question is whether it resides in your controller or spread across the brains of your personnel. Now, consider a similar VxLAN EVPN fabric built with HPE's Apstra. Next, I will again simulate an EVPN control plane fault. This will specifically disrupt route advertisements for the endpoint connected to Leaf 2, causing it to become unreachable from the fabric, despite the endpoint itself remaining locally connected and operational. In the Analytics tab, the MAC monitor probe flags a single missing MAC address. Drilling into the probe confirms that the endpoint is still locally present and operational. Rather than waiting for user complaints, operators are proactively alerted to anomalies between expected and actual routes in the fabric. This control plane issue is made visible through the combination of context and telemetry. This kind of control plane failure is no longer hidden amongst the noisy telemetry. Its signal is raised to the attention of Apstra operators upon detection, the timers of which are also customizable. What differentiates Apstra is context. Telemetry alone shows what exists in the forwarding table. Telemetry combined with context reveals what should exist. This alignment enables rapid detection of silent failures and significantly improves signal-to-noise, allowing operators to quickly isolate and prioritize issues that would otherwise go unnoticed. Apstra also has pre-built context-aware probes for BGP monitoring, EVPN host flapping, Type 3 and Type 5 route validation, as well as dozens of other probes that use context and telemetry to turn data into actionable insights. Why struggle with legacy controllers that externalize the cost of day 2 operations onto your expert personnel when you can deploy a controller that does the heavy lifting for you?